Hey everyone, Mike here from ArnoldTutoring.com with a pretty difficult integration question. We can see we have an indefinite integral and it says to solve for it. We know it's indefinite because there's no limits here on the end. So it's not from a number to a number, it's just indefinite, so we know our answer is going to involve some x's and we'll have a plus c on the end because it's not a definite integral. Okay, so now we look what's inside the integral. We have x to the 7 times the square root of 1 plus x squared. Normally when we have the square root sort of trapping a particular x term, it's very good to think about substitution. Substitution where we make whatever's under the square root equal to u. So let's start with that. So I'm going to make whatever's under the square root equal to u. Great. Now we know whenever we do this we also have to do du, which is just differentiating the right side in terms of x, which is going to be 2x dx. Great. So we know once we do u substitution that we have to get rid of everything. And what I mean by that is that we need to basically transform this integral into an integral in terms of u's only. So right now we would be able to get rid of 1 plus x squared because we called that u, and we'd be able to get rid of 2x dx because we're calling that du. So we can get rid of the dx, kind of put a check mark by that, and we can get rid of one of these x's out of the 7, which means we need to replace another x to the 6. So let's kind of take an intermediate step here and look at where we're at if we were to substitute out what we can right now. We would be left with x to the 6 still. I'm going to actually just rewrite this first. X to the 6 times x, I'm breaking out one of the x's there, times the square root of 1 plus x squared dx. So now I look at what I have in terms of u, and I can rewrite this as x to the 6, I can't replace that yet, times x dx. Well, if we want to isolate x dx here, I would just divide by 2 both sides. So I can get rid of x and dx by calling that du over 2. And we're calling 1 plus x squared u, so this is the square root of u. So we're almost there. We've just got to continue to somehow express x to the 6 in terms of u. Well, let's look at what we called u. We called u equals 1 plus x squared, which means u minus 1 equals x squared, if you just subtract the 1 to the other side. And we want to get x to the 6 in terms of u. So how do we get x squared in terms of x to the 6? Well, we just take it to the power of 3. Do that to both sides, and we can say u minus 1 to the power of 3 equals x to the 6. So we can substitute that in here so that our whole integral is now in terms of u. You can see once we're at a stage where there's no more x's showing, that's when we're ready to actually do the integration. So this is going to take some work, but we're up to it. It's obviously going to work best if we simplify everything, so we actually multiply it out. So u cubed, or u minus 1 all cubed, sorry, comes to u cubed minus 3u squared plus 3u minus 1. If we don't know that, we can just actually do the FOIL with the first two brackets. Root u du over 2. I'm going to take that half out to the front because we know that we can bring constants out to the front. And when we multiply this root u into this whole bracket, it's going to add 1/2, which is the power when it's root u, to each of the exponents. So u to the 3 becomes u to the 7 over 2, minus 3u to the 5 over 2, plus 3u to the 3 over 2, minus u to the 1/2 du. Okay, so now we're actually ready to do the integration. The 1/2 is still up front. We go up a power and divide by a power when we're going by polynomials. So this becomes u to the 9 over 2 times 2 over 9 minus 3u to the 7 over 2 divided by 7 over 2. So it cancels. plus 3u to the 5 over 2 divided by 5 over 2 minus u to the 3 over 2 over 3 over 2 plus c. Okay, so we're basically done here. However, you always have to use or leave the answer in terms of the same variable that it was given. So there weren't u's given in the question, there were x's given. So now we've got to replace every u by 1 plus x squared, which is what we called u in terms of x. So let's do that. Okay, so we have 1/2, open bracket, 2 over 9. U was, again, 1 plus x squared to the 9 over 2 minus 3, 1 plus x squared to the 7 over 2 over 7 over 2 plus 3, 1 plus x squared to the 5 over 2 over 5 over 2 minus 1 plus x squared to the 3 over 2 over 3 over 2 close plus c. Excellent. So this is a difficult question. Here's your final answer. What made it difficult? It was the fact that we actually had to rearrange our u equation. We couldn't just straight sub in everything and it got rid of all the terms in terms of x. We had to sort of move around within our u equation to actually get x squared on its own. The reason we knew to do that was because you want to make your best guess for the substitution, then actually do the substitution. So plug in u where you can, and then see what else you have to substitute out. So we knew there was still an x to the power of 6 that we hadn't substituted, which meant we needed x to the power of 6 in terms of u somehow. That's your clue, and then don't forget to change out of u back to x at the end. Difficult question, but if you stay within those kind of main steps for u substitution, you'll be all right. You can always send us more questions, info@arnoldtutoring.com. Thanks.